Hi, Assalamualaikum. I'm going to talk about question 1 in our tutorial chapter 9 carbonyl compound. Okay, you are given 5 compounds A, B, C, D, E, and you need to name each of them. The first compound is having a cyclohexane, and one carbon has a carbonyl group, meaning the carbonyl carbon is inside the ring. So this is not a benzene. It doesn't have any alternate double bond. This is a cyclohexanon. Okay, let's write that down. Cyclohexanon. Okay, next B. This is actually a straightforward naming where if a benzene ring is attached to a carbonyl carbon, it is called a benzaldehyde. Third question C. Let's count the longest chain in this compound, which is 1, 2, 3, and this is a substituent phenyl attached to carbon number 1. So the name would be 1-phenyl. And then 3 carbons mean it is a propan, so no dash there. Propan. 2, because this is a carbonyl carbon, it has double bond O attached to it. And then on, this is a ketone. Next question for structure D. CHO means it is C double bond OH. And then it is attached to all of this. So we also need to calculate or count the longest chain 1, 2, 3. This is a propanol. Okay, write down propanol. And then at carbon number 3, we have a phenyl. Okay. And finally, number E, this is a ketone where the second carbon is having a carbonyl group. So how many carbons are there? 1, 2, 3, 4, 5. This is a pentan. 2 on. All right. There you go. The list of the answer for 1A. B. Which of these compounds are aldehydes and ketones? We need to know the difference between aldehyde. Aldehyde has a C double bond O attached directly to hydrogen. So this carbon has to be carbon number 1. Aldehyde in this case is a B and then a D. This is aldehyde because, as you can see, at the end of the compound you have a C double bond O attached to H. But ketone, on the other hand, has the carbonyl carbon attached to 1 and 2R. So basically, there is no H attached to this carbon. This ketone or this carbonyl carbon in ketone, it can be carbon number 2, 3, 4, 5, however you're going to have the ketone. So here, cyclohexanon is a ketone. This one has C double bond O in the middle, and you have a CH3 methyl attached to it and a benzyl attached to it. This is called benzyl. Okay, but we're not going to use benzyl in the IUPAC name because we want to get the longest chain. Benzyl is having CH2, but phenyl is just like that. You have to know the difference between the two. Another ketone would be this one. Okay, this is a ketone. There are 3 ketone and 2 aldehyde in this question. For part C, we are going to choose which one of this A, B, C, D, E are going to react with Fehling solution. Fehling solution, if you still remember in our table here of practice 9.4, it will react with aliphatic aldehyde only. Sometimes we need to refer to this table, but it's actually something that is easy for us to remember, whereby for Tollens, Fehlings, Benedicts, and Schiff, generally, they're going to give a positive reaction with aldehyde. So let's choose which one of these are aldehyde. B is an aldehyde, so it will give a positive result with Fehling solution. D is also an aldehyde, so D is going to give a positive reaction with Fehling solution. Now, iodine with alkaline is an iodoform test. It is wanting to detect the existence of a methyl carbonyl group. So, whether it is aldehyde or ketone, if it has a methyl group attached directly to the carbonyl carbon, then it would become a positive reaction. If reacted with iodine in alkaline, the positive reaction would be yellow precipitate occur. So which of our compounds here have a methyl group attached to the carbonyl carbon? I can see directly that it is C. Okay, as you can see here, C double bond O is attached directly to a CH3. So this is a methyl carbonyl group. Another one is this one, C double bond O, and on the left here there is a methyl group. So C and E would give a positive reaction result when react with iodine in alkaline. Now, which one of these is going to become primary alcohol when reduced? So the answer would be aldehyde, because it is going to be reduced to become CH2OH. This is primary alcohol. The end of this compound also is going to be CH2OH. But if you try to do reduction on a ketone, for example, you're not going to get a primary alcohol. For example, you want to do a reduction on a ketone here, you are going to get, okay, let's say we use NaBH4. Okay, you are going to get CH3, C, and you're going to attach OH, and then this is the right R for this ketone, and you're going to have one H here. So see, this is not a primary alcohol, this is a secondary alcohol. So you know straight away that you're finding aldehyde, not ketone. Question E, select the list above a compound which can be converted to compounds below and show the conversion by using equation. So we want to produce the compound that is given. We have to find the compound that has the nearest structure to this. So I believe it is D. Why? Because it has a benzene ring. Yes, that's the first one. And then it has 1, 2, 3 carbon. 1, 2, 3 carbon, where the carbonyl group is at the end of the compound. So from this aldehyde, okay, let's do reduction first. So basically, the previous question is giving us a clue on what to start when doing this conversion. So I like drawing phenyl like this. So this is our CH2, CH2. What are we going to do now? Oh, reduction. NaBH4. We are going to produce CH2OH. This is the primary alcohol that we're going to produce. The tips or the clues given by the previous question. Now, after this, how are we going to convert OH into Cl? This is a reaction that we've learned in chapter 7, haloalkane. No, yeah, synthesis of haloalkane, and also chapter 8, nucleophilic substitution of alcohol. So what we're going to use is maybe PCl3. Okay, we are going to replace or substitute the hydroxy compound with, I don't actually have to draw this back because I can just do like this. See, we can also use PCl5, yeah, or thionyl chloride, SOCl2. CO2 or CO3. Okay, so next we want to produce this structure. We have a carboxyl group. So if we have a carboxyl group here, it might start from CN. So when it has a CN, and also OH, the carbonyl group must have reacted with HCN. So this would be a ketone in the middle. So maybe we can use this compound. Okay, we react this with HCN, and then we are going to get a compound where we have CH2 and then C, CN, OH, CH3. Yes, and then we are going to react the compound with H2O and H plus with heat. Okay, so we are going to get a compound where we have CH2, the CN is going to become a carboxyl group. This one will stay as OH and CH3. This is basically the compound that we want here. Okay, so we're going to get 2 marks here for question number 1E2. Well done, everybody. If you've got the same answer as the one that I've presented to you, Alhamdulillah. So that's all. Assalamualaikum warahmatullahi wabarakatuh. Bye.